So in this lecture we are going to find work done by the conservative field. So this is the question. Show that f is equal to 2xy plus z cube I plus x square j plus 3xz square k is a conservative force field. Find the scalar potential. That is the second question. Find the work done in moving an object in this field from point 1 minus 2 1 to 3 1 4. So let's start. Show that this is conservative field. So if it is conservative, then its curl should be 0. So to show it that it is conservative, we have to show that grade of curl of f is 0. So that implies that the determinant I, j and k partial x partial y and partial z 2xy plus z cube x square and 3xz square. So this is the curl of f. So you see I component. So you have to differentiate this component with respect to y, which is 0, there is no y, then this component, and this with respect to z, so that is again 0. J, we have to differentiate this one with respect to z, so that will give me 3z square. And this last one with respect to x, so that is 3z square. And then k, so they cancel. In k you have to differentiate this with respect to x, so that is 2x minus, and this with respect to y, that is minus 2x. So this is, so the curl of f is equal to 0 vector 0 0 0. Okay, that implies that, which implies that f is conservative. Okay, second question, find the scalar potential. Now we studied it earlier that if f is conservative, it can be put in the gradient of y. So this implies that 2xy plus z cube I x square j and 3xz square k. So that is the field force F, and grade phi mean partial by partial x phi I partial phi partial y j and partial phi partial z k. Comparing these two, so the I component give me partial by partial x is equal to x component, which is this one, 2xy plus z cube, and then partial phi partial y is equal to x square, and then partial by partial phi partial z, This is equal to 3xz square. So we have to integrate these three equations, the first one with respect to x, the second one with respect to y, and the third one with respect to z. So this will give me, here is the phi. So when I integrate this one, I will get phi is equal to, with respect to x, it will give me x square y plus z cube x and plus some function of other variable which is y and z. Okay. So that is the first integration. The second integration is phi is equal to, with respect to y, so this is x square y and some function of the other variable which is which is x and z. And the third one give me phi is equal to, so with respect to z, so this is x z cube plus some function of the other variable, so that is xy. So all of them are phi, so we have to collect terms of the phi in such a way to get one phi. We see, so purely x function is not present in these three. Purely y function is also not present, and purely z function. So all are sharing function. This is x square and y, so no purely x function, y function and z function. So now, so if there are purely x function, we have to pick that, and y and z. But there are not purely x, y and z function, so we come to the conclusion that there are all the term will be max 1. So a function of y is z. So we have to search out in all the three function of y z. There is no function of y z. Okay, so that means this function is a constant. Here, a function of x and z. X and z have function. You see over here, this is a function of x and z, and similarly this is also a function of x and z. So write that function x z cube x. Okay, then there is a function of search out function of xy. So we see that the function of xy is present. So that is a function of xy, x square y, and this is purely a constant function. So this is the required potential. For this conservative field, this is the scalar potential. So we did two questions. The field is conservative and we find the scalar potential. This is the scalar potential. Now the third part is work done moving an object from point 1 minus 2 1 to 3 1 4. So that is the question we have to attempt. Work done, the field is work is equal to f dot dr, integral from first point which is 1 minus 2 1 and to the end point, that is 3 1 and 4. So from this point to this we have to find the work. Okay, as the field is conservative, so we can put we can put the gradient of I over here. So f is equal to gradient of I dot dr. But we know that the product of these two is d phi. The product of these two give me d phi. So the differential and integral cancel out. Phi from the initial point to the final point. Okay, so what is phi? Phi is in the, so this is z cube x square y plus c, that is phi, and this phi from this point 1 minus 2 to 3, 1 and 4. So putting the upper limit, this is 3, so that is 3 cube and into x, 4 cube. Z is 4, so 4 cube and x is 3, so we're multiplied with 3. This is multiplication. Plus x square mean 3 square multiplied with y, which is 1, and plus c. So that is the upper limit minus the lower limit. So z is 1, so 1 cube multiplied with x, which is 1, minus x square, that is 1 square, multiplied with y, that is minus 2, and plus c. So the work done is equal to, this is 64 and multiply with 3, so 192 I think. So 192 plus 9 and plus c minus, you see 1 and my plus 2. So this is 1 and plus 2, 3. So minus 3 and minus c. Oh no, this is 1 and here is plus, this is the plus sign. This is 1, you see here is plus. So that is 1 minus 2 minus 1. So this is plus 1. This is plus 1. Oh, C cancel out, and 192 plus 10, so that means 202 units work. So this is the work done. By the conservative field moving the object from this point to that one. Okay. Now show that necessary and sufficient condition that f1 dx, f2 dy, f3 dz be an exact differential. Is that curl of f is 0, where f is this. So we have to prove that curl of f is necessary and sufficient condition for this value to be exact differential. So I'm solving A. Let f1 dx, f2 dy, and f3 dz is exact, then we have to prove that curl of f is 0. Curl of f is 0 vector. Okay, so if this is exact, then we can write this implies f1 dx, f2 dy, and f3 dz. If it is exact, that it should be equal to d phi, but we know that d phi is partial phi partial x dx, partial phi partial y dy, and partial phi partial z dz. Now comparing these two, the dx coefficient is f1 here, and on that side it is partial pi partial x. Dy coefficient is f2, that is partial pi partial y, and the dz coefficient is f3, that is d phi dz. So the f, which is equal to f1 I, f2 j, and f3 not vector, f3k. This is the field. Now the value of f1 is this is partial phi partial xi, partial phi partial yj, and partial pi partial zk. Okay, so that is the value. So what that mean? That mean that the force field is gradient of phi. This is in fact gradient of phi. So taking the curl on both sides, this is phi. So you see these are two vectors in the same direction, so this is 0. Curl of graded phi is 0. So that means curl of f 0. So if this expression is exact differential, that implies curl of f is 0. Now we have to prove the converse. If the curl is 0, then it should be exact differential. Okay. Now converse. If the curl is 0, curl of f is 0, it should implies f1 dx, f2 dy, and f3 dz is exact differential. If curl of f is 0, that implies it is conservative, and f can be put in the grade phi form. Curl of f 0, then it should be grade phi, and that implies that f dot dr is equal to grade of I dr, mean taking dot product with dr on both sides. What is this? This is this expression. This is f1 dx, f2 dy, and f3 dz, and what is on the left side, right side, that is d phi. Product of these two vectors is d phi. So this implies it is exact differential, the exact differential of phi, which implies that f1 dx, f2 dy, f3 dz is exact differential. Exact differential. Okay, so that complete the proof. So let me write on the other page. You see, I'm writing the question again. Y square z cube cos x minus 4 x cube z dx plus 2 z cube y sin x dy plus 3y square z square sin x minus x4 dz. So we have to show that is exact. This expression is exact. For that, we have to show that the force field, which is equal to y square z cube cos x minus 4 x cube z I plus 2z cube y sin x j and plus 3y square z square sin x minus x4 k is conservative. We have to show that this is conservative, then this expression will be exact. So for that we have to show that the curl of f is 0. So what is the curl of this? This is I, j and k. partial partial x, partial partial y, partial partial z. X component is this is y square, z cube, cos x minus 4 x cube z, that is x component, and then y component, that is 2 z cube y sin x, and the z component is 3 y square z square, y square z square sin x, minus x4. So we have to show that this determinant give me zero vector. That implies curl of f. So I component, we have to differentiate this with respect to y, this component, so that is 6 y z square sin x, this with respect to y and this with respect to z, so that is minus 6 y z square sin x. So you see they cancel. Then j, so this will be differentiated with respect to z, so that is 3 y square z square cos x minus 4x square, x cube, 4x cube minus, this will be differentiated with respect to x, so instead of sin we have to write cos, 3 y square z square cos x, and this will become plus because we have minus sign already, so that is 4x cube. So you see 4x cube with cancel 4x and this term with this one, so overall 0. And there is the last kth component. This will be differentiated with respect to x, so this is 2z cube y cos x, and this will be differentiated with respect to y, so that is minus 2y z cube cos x, and there is no y in this term, so that is 0. They cancel, so this is overall we have 0. Curl of f is 0, that means f is that implies f is conservative. If it is conservative, then f can be put as grade phi. Yeah, but we have to take this as exact differential now, because this force field is conservative, then this differential is exact. Okay, so y square z cube cos x minus 4x cube z dx plus 2z cube y sin x dy plus 3y square z square sin x minus x4 dz. Now as the field is conservative, so it is exact differential. What is this exact differential now? This is partial phi partial x dx partial phi partial y dy partial phi partial z dz. Comparing on both sides, so partial phi partial x is equal to the x component, that is y square z cube cos x minus 4x cube z, partial phi partial y is equal to 2z cube y sin x, and partial phi partial z is equal to 3y square z square sin x minus x4. Integrate the first one with respect to x. We have pi is equal to y square z cube sin x, and with respect to x, this is x4z, and then a function of the other variable, which is y and z. Now integrate this one with respect to y, so phi is equal to z cube y square sin x plus some function of, let's take this to be g of x and z, and this will be integrated with respect to z, so phi is equal to, with respect to z, so that is y square z cube sin x and x4z, and plus some function of, let's take it to be h xy. Now we have to collect phi from this, so simply you see this function is written twice, this is written over here and here, so that is y square z cube and sin x, and this function is written this is also written over here, so this one and this one and this one, so that is this function. Now this function is written over here and here, so that is minus x4z and plus some constant, no other term is remain, so this is 4. This is the corresponding potential function. And that's all. So if this video help you, then like, comments and subscribe.